Here's experiment 7, part A. We are going to be finding the specific heat of an unknown metal. Our unknown metal is metal A, so you can write that as unknown metal A. We are to get approximately 10 grams of metal A. So here I will place a weighing dish on the scale, zero it, take it off, and add some of metal A. Now it's recording the metal itself, so we will record this mass measurement as the metal's mass, 10.319 grams. We're also going to go ahead and get our mass of our empty calorimeter. So here is our calorimeter. Our empty calorimeter, we will record its mass as 8.595. The procedure says to add approximately 20 milliliters of water to the calorimeter. So here's approximately 20 mils of water. I'll add it to the calorimeter, and we'll take the combined mass. We will record this as the mass of the calorimeter and the water as 29.116. Okay, I will now take my metal A that we massed out a minute ago, pour it into a large test tube. Now place this in boiling water. For at least 5 minutes so that the metal will become the same temperature as the boiling water. That will allow us to have an initial value for our temperature of metal. After 5 minutes of heating, I'm going to record the temperature of the water bath. This thermometer has tick marks at every 1 degree, so I need to estimate to the 10th degree. So this will give us the initial temperature of the metal. We're assuming the metal is the same temperature as the water bath, 98.1. So 98.1 is our initial temperature of the metal. The initial temperature of the water will come from our graph because the temperature probe is in the water, in the calorimeter. So I will be transferring the hot metal to the water. The water is starting around room temperature, so we will be able to get the temperature of the water from the graph. And I'll be putting over the metal and starting the graph. The graph's temperature will rise. So I'll begin the graph. It's plateauing with the initial temperature of the water in the calorimeter. What I will then do is I'm going to, as quickly as possible, transfer the hot metal into the calorimeter. Trying not to let heat escape. I'll cover it as quickly as possible, and I'll swirl. What's happening is the energy from the hot metal is being transferred to the water. So the water's temperature is increasing. Our temperature probe is recording the temperature of the water. I'm going to continue measuring the temperature of the water until it plateaus at its highest mark, because when it reaches its maximum, that's the end final temperature. That'll be the final temperature for the metal and the water. So using the graph, you will get the initial temperature of the water, and you will get the final temperature of both the water and the metal.